Hi guys, so today we're going to be talking about some Stat 3000 stuff, specifically conditional probability. So why would we want to talk about this? Well, it's actually really helpful in the real world. They use conditional probabilities to talk about genetics and figure out the likelihood of getting certain genes. It's also used in sales to try and determine the likelihood of making a sale. Plus, in this class, your Stats 3000 class, it's going to be super helpful later. You can use conditional probability to find independence, and you can use conditional probability to find other conditional probabilities too. You'll learn about that later, but for now, let's talk, what is conditional probability? Basically, it's the probability an event occurs given a second event occurred. So we notate it as shown on the screen. It's the probability, P parenthesis, of A given B, or A line B. So this is how we write it when we are looking for the probability of A, knowing that B has happened. Well, how do we know how to find that? Well, in this picture on the left, you can see you've got one circle, that's circle A, the probability of A, and the circle on the right is the probability of B, and where they cross is the probability of A and B, or A intersect B. That's that orange area. Now let's just look at the probability of B. You've got that orange area still, and it's a part of B. Now when we're looking at probabilities, to find the probability of a part in a whole, you take part divided by whole, right? So for this case, it'll be the probability of A intersect B, all divided by probability of B. Or this formula here. Again, our notation is probability of A given B is equal to the probability of A intersect B, all divided by the probability of B. Let's try some examples. This first example, let the probability of A intersect B equal 0.4, and the probability of A equal 0.8. What is the probability of B given A? Well, let's go back to that formula we found. Probability of A given B is probability of A intersect B divided by probability of B. So, in our problem, we switched up the letters. We're looking for probability of B given A. So, probability of A intersect B, we were told, is 0.4. And the probability of A, we're told, is 0.8. So, probability of B given A, which equals probability A intersect B, over probability of A is equal to 0.4 over 0.8, which simplifies to 0.5. So probability B given A equals 0.5. Let's try another example. This one's a word problem. It says, at Wendy's, the probability someone wants a chocolate frosty is 0.6. The probability of someone wanting a chocolate frosty and a small fry is 0.2. Knowing that, what's the probability someone will want a small fry given they ordered a chocolate frosty? Well, what do we know? We know the probability of chocolate is equal to 0.6, and the probability of small fry and chocolate frosty, or S intersects C, equals 0.2. Well, what are we looking for? Let's see. The probability someone wants a small fry given they ordered a chocolate frosty. That given is an important word. Given tells us that we know that, right? So we're given they ordered a chocolate frosty, and we want small fry. So the probability we're looking for of A given B is probability of small fry given chocolate frosty. So let's look at this formula here and apply it to our problem. We want probability of small frosty given chocolate. So that is equal to the probability of small fry intersects chocolate frosty divided by the probability of getting a chocolate frosty, or 0.2 over 0.6, which is 1/3 or approximately 0.333. Great job! So again, go back to review. We found the probability of A given B, or the probability of knowing event A happened, knowing that probability B will happen, is the probability of A intersect B, A happening and B happening, divided by the probability of B happening, that thing that we know will happen. Awesome, here's some resources I used.